Okay, now we're going. Think this will work. Am I? Oh, okay. Back on track. All right. So remember when we're trying to solve something like this. Remember that the process we do completing the square, we first have to write this in the form x squared plus bx equals c, right? Where b is just some number and c is just some number.
Yeah.
So for us right here, what would we have to do to put it in that form? Yeah, we have to add -1 or subtract 1 from both sides, add -1, same thing. So we'd end up with x squared plus 6x equals -1, right? And we would then have to figure out a couple things. You have to fill in, we talked about filling in some boxes, right? So we'd have to fill in what we're going to add here and here in order that what we get on the left side becomes a perfect square trinomial, meaning a trinomial that's going to factor into the same factor times itself, or the same factor squared, one factor that's squared. So all this stuff would then have to become x plus some number squared, which would then be equal to just some number on the other side, right? So we're really just filling in 3 boxes. We're filling in, I know we fill in the blue box twice, but it really is just 1 box. We're really just filling in 3 boxes to complete this process, right? We want to know, in Moodle, the question is asking here, essentially, what goes in the blue box? That's all it's really asking, is what number would I have to add to x squared plus 6x so it became a perfect square trinomial that factored into a perfect square? What's the answer? It's 9. Yeah, it's 9 because it's going to be, whatever b is, it's going to be half of b squared, right? In the process, I think that's the second box you fill in, though. What's the first one? Green, blue, or red? Green, yeah. We fill in the green one because we know that whatever the number is in front of the x, half of that is what we're going to add to x to create, we know that's going to be our factored perfect square, right? After we fill in the green box, we know that in order to build that, the blue box has to be that squared, right? So it's going to be 3 squared, which is 9, right? And then finally on the other side now, we know that whatever we had on the other side, call it c, plus half of b squared is going to be what, 8? And so now this is easy to solve, right? Instead of having an x squared term and an x term, all we've got is just an x term that I can isolate by reversing order of operations. And the 2 steps are going to be the same every time. What are the 2 steps to get the x by itself? First, I do what? Square root, get rid of the 2, the squared, and then subtract 3, or add 3, right? That's it, okay? That's the process. I just want to demonstrate for you that by adding, that this part works, right? Let's just look at this. We got this part over here. Are they the same? Yeah, they are. X squared plus 6x plus 9. If we factor that, we know that's the template that fits. Well, what are the 2 numbers that multiply to positive 9 and add to positive 6? 3 and 3, right? So it works. I get x plus 3 times x plus 3, which is the same thing as x plus 3 squared.
So why do you have to do that?
Yeah, I mean, if you're completing the square, yeah, you do. That's the whole point, is that if we can make this thing factor into the same factor times itself, that's x plus 3 squared. And the benefit of that is, look what we got. We got a single x in this equation, so I can just isolate it then, right? This went from being one of the harder kind, where we have to factor, to one of the easier kind, where we can just isolate x, right? That's the whole strategy behind completing the square to solve a quadratic equation, okay? So real quick, what's gonna be the value of C there? What's B? 9. So what's half of B?
4.
Okay, 4.5, but we don't really want to use mixed numbers. I mean, maybe you think a decimal, but just leave it as a fraction.
Too mean.
So so half of 9 as a fraction is what?
4.5. Oh.
It's just 9 over 2. That's it, right? So B is just 9 over 2. So then, B over 2 is 9 over 2. Half of B is 9 over 2. And so then what am I going to do to get the number I add to x squared plus bx? Just square that, right? So what's that going to be then? Because there's a question maybe about that. What happens if we square 9/2? Well, if 9 over 2 reduces, which it doesn't in this case, we would do that. Like what if that were an 8 over 2? We wouldn't even be having this discussion because 8 over 2 is 4, right? The reason we're having this discussion is because it doesn't work out to be an integer, right? All you do though when you square a fraction is what? No big deal. What do you do? No, if I'm going to square 9/2, well, what do you think? I mean, if I square 4.5, I'm just going to get some big long decimal number on my calculator, right? Okay. What do you think I would have to do to get the same fraction here?
Square the top and
Square the top and square the bottom. That's it. It's just equal to 9 squared over 2 squared, which is going to be 81/4. That's the answer. Okay. How about that one? What's B? 1/4, right? So we need to know if B is 1/4, then B over 2, if dividing by 2 is the same as multiplying by 1/2, right? Multiplying by 1/2, same thing as dividing by 2. So B over 2 would really be the same thing as taking B times 1/2 in this case, because I'm starting with a fraction. It's probably easier to think of it as multiplying by 1/2. What's our rule for multiplying fractions? It's easier than adding.
go straight across.
Straight across. So 1 times 1 is 1. 4 times 2 is
8.
So half of B is 1/8. So then what is the answer going to be here?
1/6.
Yeah, just going to be 1 squared over 8 squared, which is 1 over 64. So that's it. Okay, no big deal. All right, so next thing then is to actually do this process. Let's go back and remind ourselves how to go through the process of completing the square. So what I want in Moodle on these kinds of questions, if you read this, and you got to read these carefully because I'm asking for specific things. I want you to go through the process of completing the square to solve the equation, but you don't have to solve it. All I want you to do is enter the equation corresponding to the step before you start to isolate x, right? So we want to get the one that looks like x plus some number squared equals some number, right? A and B are just numbers. So what do we do first? What do I got to do to this to complete the square? Okay, good. I've got, say it again. Isolate, okay, I'm going to isolate the variable. Before we can do that, though, to set up the completing the square I thought I heard somebody say it. Subtract 6. Right, so we've got to make this thing make it look like the form, make it look like the form x squared plus bx equals c, right? Right?
Yes.
So we got to get rid of that 6. So that means we're going to end up with our starting place is going to be x squared plus 2x equals -6. Agreed? Okay. Before we even think about trying to fill in any blanks, though, write the next line. You know that this side over here, the whole purpose of this is to add the right number to the left side so that it becomes a perfect square trinomial, and it factors into x plus some number squared, right? Agreed? So we just got to fill in these blanks. There's a blank there. I'm going to have to add something to both sides of this, right? And then I'll be able to add up the numbers over here to fill in the final blank. And then that's where I want to be, because then I'm going to have an equation with only a single x in it that I can just isolate, right? Where do we start? Yeah, we actually start there, don't we? Right? Because what's b in this case? 2. So what goes there then? 1. Yeah. So the first thing we do, we know that that's going to be x plus 1 squared because we have to, the number that goes there is going to be half of b. So that tells us what goes there. What is it? Yeah, it's 1 squared, which is 1, right? Plus 1. I got to add that to both sides because I have an equation. Got to treat both sides equally, right? So then finally, what do we get on this side over here? -5. That's what Moodle wants right there. That's it. Right? I've completed the square. So what I've done is I've transformed this equation, which has an x squared term and an x term, into a new equation that only has an x. That's it. So I can isolate. Okay, let's go one step further. So that's what you'd input into Moodle. Let's go one step further, though, and solve this thing. So I'm going to rewrite that. X plus 1 squared equals -5. What are the 2 steps in order again to isolate x? Okay, first I square root. So if I square root both sides, the square root cancels the square. And step 1 gives me x plus 1 equals, what do I need to write on this side? Good. Plus or minus the square root of -5, right? What do I do? Let's go ahead and simplify that radical while we're at it. Well, tell you what, let's not interrupt the flow. Let's just finish it and then we'll simplify our answer. What's step 2? Okay, subtracting 1, which is the very same thing as adding -1. Good. I'm going to write it that way, though, because I think it makes it easier to see something. So if I add -1 to both sides, right, then the -1 cancels the 1, leaving me with my x isolated. And on the other side, I get -1 plus or minus the square root of -5, right? So let's simplify that. So x, there was step 2, I guess, also. So x equals -1 plus or minus. And then what do I do with that negative inside the radical? Yeah, that means I'm gonna make that the square root of +5 times the square root of -1, and the square root of -1 is just I, right? So I'm gonna get I times square root of 5, and I'm done. How would I input that in Moodle when it asks me to write each solution separately with a comma in between?
-1 plus.
Yeah, good. So I'll use the plus for 1. So I'll have 1, -1, plus I radical 5, comma, -1 minus I radical 5. Does it matter if the I is before or after the radical? You're not gonna get it marked wrong if you put it behind. It's fine. Only reason we don't remember is just so you can't make a silly mistake, or so you don't wonder if the I is inside the radical, because it's not. Right? Okay, another one. Questions on that? Okay, let's try another one. This one. Okay, so once again, we've got to get this into the form before we can complete the square. We have to get it into the form x squared plus bx equals c, right? So what 2 things, what 2 things do we have to do here? This is a little bit different. What 2 things are different in this equation than what we want it to be like? Okay, I've got a negative in front of the x squared, which means we're multiplying x squared by what number? -1. And then I've also got that plus 10, right? So there's 2 things I've got to undo here. Let's go ahead and, how about if we just subtract 10 from both sides to get that on the correct side, right? C needs to be on the other side of the equation. So step 1 would then be, we've got -x squared minus 11x equals -10. What do I do about that negative sign? Because that's different than that. I can't have it there to complete the square.
Multiply by negative.
Yeah, sure, I could either multiply or divide both sides of the equation by -1, right, to get rid of that. Now what happens, let's just say we multiply. I think that's easier to think about. If I multiply both sides of the equation by -1, what is that going to do effectively to each term? Say it again. Well, it's going to make, right, okay, in this case it'll make them all positive. If they had started off positive, it would have made them negative. So in general, what's it going to do to the signs of each term? It's going to reverse them. Yeah, it's going to switch them, right? Okay, so step 2 then is we're just going to multiply each side by -1, which changes all the signs. And then that leaves us with x squared plus 11x equals 10, right? Okay, and now we're set. Now we can complete the square, right? So then we know that that's going to, we want to add something here so that it factors into a perfect square. I'd write it if I were you. What's that?
Have someone go with this one.
Oh, you want to go show?
Yeah.
All right, so this one's going to be a little bit inconvenient. What's B?
11.
Okay, so what number then? Dalton, what number is going to go? If we got phones or anything, please put those away. What number is going to go there? If B is 11. Think about what we did, right? Whatever the number in front of x was, how was that related to what our factor is going to end up being? Well, it's not convenient. It was more convenient before because we had a 2 there, and so we just got a 1, right? What's this one going to be, though? It's going to be weird. So, okay, 5.5. We'll just leave it as 11 halves. Okay, we'll just leave it as 11 divided by 2, or 11 halves. So then, what's that going to make? See you. Good luck. Have a good Thanksgiving. So what's that going to make the number that I have to add up here to create the perfect square trinomial then? What do you think? Tyler, what are we going to get? If that's 11 halves, what do I get up here? How am I going to get it? What do I have to do to 11 halves to get that number? Not times by 2. No, you're thinking, what do I have to do? Okay. Square it. Yeah. Yeah, we're going to square it. So we get 11 squared over 2 squared. Now, up here I don't even need to know what that is, but I got to do the same thing to both sides, and I'm actually going to have to add that number to 10. So 11 squared is 121 and 2 squared is 4, right? Okay, so I've got to figure out what that sum is, and that's what's going to show up there, right? So let's look at this 2 ways. Let's look at it using a calculator solution with graphing calculators. There's a nice shortcut for that. But then also let's maybe talk about how we get that answer. So if I want to add up 10 plus 121 fourths, what do I have to do to add up fractions? This is to remind ourselves how we do this. I need a common denominator, which would be 4 in this case, right? So I've already got a 4 on this fraction, but this one needs a 4 on the bottom. So what do I have to multiply both the top and the bottom by? 4. Good, so that's going to give us 40 plus 121 over the common denominator of 4, which is what, 161 over 4? Okay, so that's our answer, 161 over 4. Okay, I'm going to show you how you can do this on a graphing calculator. Just because, now what I want you to do though, you need to be able to add up fractions. We're going to do that a ton all year. So if you need some practice, do that a couple times manually, but then after a while, when you got it, just to save time, use a graphing calculator, that's fine.
Me too.
Not many people love fractions. Okay, pay attention, please. So here's graphing calculator. Here's what we can do. So I can just type in 10 plus 121 divided by 4, and it's going to give me some decimal. And if I want to turn that decimal into a fraction, I just need to go either on the math menu, but there's a shortcut. If I just hit alpha F1, down at the bottom, that fourth option means convert from decimals to fractions. So if I go down and hit a 4, what that's saying is my previous answer I'm going to convert to a fraction. And if I hit enter, it tells me 161 fourths. There's, I think, an easier way to do this, one that might make more sense to you. If I input fractions into the sum, then it's going to give me back a fraction. These new graphing calculators are pretty smart. So if I write this as 10 plus, and instead of writing just 121 divided by 4, if I actually make that a fraction, so if I hit alpha fraction template, and then I choose number 1, so I get the little fraction template that I can fill in, and I make that 121 over 4 as an actual fraction, when I hit enter, look what it does. It assumes I want a fraction back, and so it gives me a fraction. Okay, so there's a part of the test where you'll have access to graphing calculators, and so you can just do that. That's fine. Either way, I get for my answer this, right? So when I want to solve that, then so if I want to solve that, what are the two steps in order to solve that? Same as always, square root. So x plus 11 halves equals what? I square rooted the left side. You got to do the right side. What do I get on the right side? Danny, help me out here. What do I need to put on this side? Well, I'm at this point I'm just square rooting both sides, right? So, okay, you're right. You're right. So, but what am I going to write first before I try to simplify it? I just did this, right? Everybody pay attention. Look up here, please. I want to see all everybody's focus up here. So I just did this, right? In order to get rid of the square. What do I get left with on the other side? That, right? Ah, plus or minus. Good. So I get plus or minus the square root of 161 over 4. So let's talk about this one. 161 over 4 does not reduce, right, as a fraction. So I'm going to break this up. This is why we did so much review of simplifying radicals earlier. So I'm going to split this up into the square root of 161 over the square root of 4. Well, what's that? 2, right? Okay. And so 161, am I going to be able to simplify that radical, do you think? No, I'm not going to. It's not a perfect square. And if I look at my list over here of perfect squares, half of that's going to be 80.5. So all I'd have to do is just look at everything above 81. Well, 60, none of those are going to go into it. 161, right? I could try them, but none of them are going to work. And so that's my answer. Almost. Last thing I have to do. Right, so I'm going to add what to both sides? Negative 11 over 2. So my final answer is going to look like x equals negative 11 over 2 plus or minus the square root of 161 over 2. That's it. Okay. It's not that bad. It's really not. I mean, the process is, it's not terrible. So what I want to show you now is what happens if we start with a quadratic equation in standard form. So we're not going to plug any numbers in this time. We're just going to start with ax squared plus bx plus c equals 0. I don't have time to go through the process and prove this for you, but if I were to do the process of completing the square with that, what I would get the answer x equals negative b plus or minus the square root of b squared minus 4ac, that's all inside the radical, over 2a. That's called the quadratic formula. And so because we did that, without plugging in any values for A and B and C, what we came up with is a formula. So now when we want to know what the solutions are to any quadratic equation, if I just put it in standard form, whatever number is in front of x squared becomes a, whatever number is in front of b becomes x, and whatever number is the constant is c, I can just plug those into this formula to get the solutions. Okay? For example, let's take this problem right here. That's not quite ready to apply the quadratic formula, is it? What do I have to do to this to put it into the right form to apply the quadratic formula?
Add.
Okay, so I could add 3x squared to both sides to set it equal to 0. How about? So if I do that, if I add 3x squared to both sides, then I'm going to end up with negative 4x squared. Everybody agree? Minus 7x minus 3 equals 0. That looks good, but there's one thing I want you to always remember on these. I always want a to be positive. A should be a positive number. So if I need to, like in this case, if a is negative, I do the same trick we did earlier. We multiply both sides by -1 to change all the signs. So we'd end up then with, instead we'd end up with positive, whoops, I'd end up with positive 4x squared plus 7x plus 3 equals 0. And so what's my value of a? What's a? Good, a is 4, what's b? What's c? I plug those in and simplify, which, we'll go through an example when we get back on Monday, but that's it. Okay, so have you ever seen this before, the quadratic formula?
Yes.
Some of you probably have. They're a really powerful way to remember something, and this might sound kind of dorky, but it's if you ever hear like songs stick in your head. I can remember. Has everybody ever seen the show Cheers, like on old reruns of anything?
I mean, the room though.
That's many moons ago. Yeah, so that dates me a little bit, but I can remember watching an episode of that. Now I still remember this dumb song. This guy was trying to study for some test, and he sang this little song about facts about Albania, and I still remember all those facts about Albania. If ever, I'm not going to play that song, but I do have one to help you remember the quadratic formula.
Isn't that about a guy that always goes so far?
It is, yeah.
Yeah.
Okay, so here it is. I'm going to force you to watch this, and this will, as annoying as it is, you will never forget the quadratic formula after this.
Oh, yeah.
Yep.
You need to give us a little on the drinks.
Oh.